Okay, this solving this problem will improve your understanding about selecting the origin. So sometimes this model equation will depends upon origin also, from where my boundaries are starting. Okay, so as my properties are varying in x direction, if I moved my origin in x direction, certainly it will affect my model equation also. My properties are not changing in y and z direction. So if I change, okay, if I change the location of origin in the direction z and y, my model equation will not change. My model equation will remain same. It will be one and same thing. So it all depends upon the changing direction. So here proper velocity was changing in x direction. Hence, when origin was selected, so there will be two model equation for this case. One model equation will be for the origin at the top surface, for origin at the top surface. I will get same model equation, and one model equation will be for origin at bottom four surface. This is clear to everybody? So there is a possible 8 origin. Okay, this is what I am telling. This is already we have solved the problem. So 1, 2, 3, 4. Similarly, 4 at a bottom face. Okay, similarly 4 at a bottom face. Okay, so this will be 8 origin. So if there is a change in origin, so there is a change in model equation also. This is again same thing, but absolute value will remain same. Absolute value means give the value of x. What is the value of shear stress? You will get same value. Means value of system. What is the velocity in a given system, that will remain same. Only model equation will change because I am changing. Here x equals to 0, I am getting velocity equals to 0. There at x equals to delta, I am getting velocity equals to 0. Okay, that equation. So if I compare this equation, okay, this is the equation actually. This is the velocity profile and flux profile. So can you see both the equation now? Okay, so this is the velocity profile equation when my x is starting from the top surface. And this is the velocity profile equation when x is starting from the bottom surface. This is the flux equation when x is starting from top surface, and this is the flux equation when x is starting from the bottom surface. So if you put, say, from top x equals to 0, this is at the top surface. At the top surface x equals to 0. For this case, flux will be equals to 0. For this, at the top x equals to delta, flux equals to 0. So absolute system value of the property remains same. So average value you will get same, mass flow rate you will get same, velocity value you will get, only what will change will be the model equation. That is very important point you need to remember. Model equation depends upon a location of origin. If you change the location of origin, in which direction the properties are changing, certainly you will get a different model equation. So whenever you are using any model equation and it is, say, flux profile equation, and it involves a location information, so at which point which properties are explained, so you must know from where this origin is starting. This is clear to everybody? Roll number 70, Darshan Dhote. Roll number 70, PT 1870. Darshan. Darshan. Yeah, just you are switching on a mic. Everything is working fine on your end. I know your mic is working properly, your speaker is working properly. Only the your that intention is not proper. Intention is not student. This is you are cheating yourself. Darshan, very good.
हेलो.
हाँ,
यस सर. मैं एम आई
बोलो
ऑडिबल
क्या
सर?
रीजन है? कुछ तो भी नया रीजन दो. अभी 2 साल हो गए ऑनलाइन पढ़ा पढ़ा के, हमको भी अभी एक ही एक रीजन सुन के हम परेशान हो गए. इंटरनेट काम नहीं कर रहा, माइक काम नहीं कर रहा, स्पीकर काम नहीं कर रहा. अभी बोलो कि ब्रेन काम नहीं कर रहा करके मेरा. ऐसा रीजन दो कुछ तो भी. हाँ बोलो
नो
क्या
सर.
रीजन है.
नथिंग लाइक.
हाँ
सर
बताओ, क्या
मैं
बताया मैंने
लाइक
अभी.
सर कि सर अगर ओरिजिन अगर दूसरा ले तो बस मॉडल इक्वेशन चेंज होता है, पर
हाँ
मैक्सिमम वेलोसिटी, एवरेज वेलोसिटी वगैरह सब सेम ही रहता है.
हाँ, और मॉडल इक्वेशन कब चेंज होता है?
अगर ओरिजिन चेंज किया तो.
सो यहाँ तो 8 ओरिजिन है, फिर 8 मॉडल इक्वेशन है कि अपने पास. ये देखो, ये कॉर्नर, ये कॉर्नर, ये कॉर्नर, ये कॉर्नर, ऊपर के 4 कॉर्नर, नीचे के 4 कॉर्नर, 8 ओरिजिन है. सो 8 मॉडल इक्वेशन है क्या?
सर एक के लिए अपन ने डिराइव किया है.
हाँ हाँ, दूसरे के लिए तुमको डिराइव करने को बोला, और बाकी के 6 एग्जाम में आएंगे क्या? कितने मॉडल इक्वेशन रहेंगे इधर? 6 ओरिजिन, 8 ओरिजिन है तो
8.
8 इक्वेशन आएंगे क्या? वेरी गुड. और तुम्हारे दोस्त कहाँ है? क्लासेस अटेंड नहीं करते. कौन है? रोल नंबर 49 है ना शायद तुम्हारे साथ में.
यस सर.
क्या नाम है उसका?
जयंत.
जयंत. नाम तो बढ़िया है यार, जयंत, दर्शन. उसको बोलो क्लासेस अटेंड करने के लिए. क्या रोल नंबर 2 अभिषेक?
Hello.
हाँ, why whether we will get 8 model equation?
Sir, we'll be getting same values of tau zs and vz. So,
No, no,
but
no.
yes, sir.
8 origin we will get 8 model equation.
Yeah, yes, sir. So, we'll be getting the same values, but the different. Only the origin will be shifted, so it will be
तो कितने
right.
ओरिजिन है ये सिस्टम के लिए?
So 8.
तो 8 मॉडल इक्वेशन मिलेंगे क्या?
No, sir.
कितने मिलेंगे?
So only one.
Only one model equation I am talking. This is
Sir,
model equation. This is model equation.
it's a two for tau z, tau xz and vz.
अच्छा, ये दो इक्वेशन हो गए. तो
Yes, sir.
ऐसे 8 ओरिजिन के लिए 8 सेट मिलेंगे क्या?
Yes, sir.
रोल नंबर 5 आदित्य.
Yes, sir.
8
So
इक्वेशन
we'll
मिलेंगे, 8
no,
इसके लिए.
so we'll get two equations for the top points and for the bottom points.
Why it is so?
So reason I don't know, so but when we derive that, we'll get for the top origin
Yeah.
points. Will
It means that you people are not at all listening. Just a couple of minutes back, I explained this detail. Let's see who knows. Roll number 12, Anand.
Yes, sir.
Yeah, tell me.
Velocity is changing in x.
Okay.
So we will get two equation.
Why not 8 equation? Now look, we are studying only one problem. Okay, and this problem is very simple. So solving this problem will not be the thing you will be designing in future. You will be designing complex thing. You will be trying to solve the complex thing. The main intention of solving this problem is you should understand and generalize the thing. Once you understand the fundamental and generalize the thing, then whatever complex thing you will come across, you will be able to solve the problem. That is main intention of solving this problem. Otherwise, flow over flat plate, there is no such case exist in real life. Flow over flat plate in chemical engineering, where I'm not aware of such a case physically exist. But this is very simple problem. First of all, simplicity is there in Cartesian coordinate system, and secondly, only one velocity and changing in only one direction. So that all assumptions are added so that you will learn this problem properly and generalize the thing. Now you generalize the thing. Roll number 15, Sai.
Hello, sir.
Yeah, tell me.
Sir, because the four, I mean to say, top four edges corners are there, na sir. For those four corners, we will get the same x direction, and bottom four corner directions, we will get the different x direction, sir. That's why we are getting two different equations for the top and bottom, sir.
But why it is changing only in x direction?
Sir, because our velocity Vz and our P is direct dependent on only x, na sir.
Yeah. So instead of Vz and P, you can generalize property. If
Yeah,
the
okay.
property is not changing in any of the coordinate direction, is not changing, so I will be getting same model equation. So here we are discussing velocity and flux, momentum flux. This is true for temperature also, this is true for concentration also, this is true for any property. If my property is not changing, I am likely to get same equation at all points. If my properties are changing, then only I will get a different equation. Okay, so here the interest property of interest is velocity. Velocity is changing in x direction, velocity is changing in pressure is changing in x direction. Hence, if we shift the origin in x direction, then I will be getting a different model equation. But you should remember here x starts from a bottom plate. Okay, x starts from a bottom plate. At x equals to 0, there is a solid liquid interface, and at x equals to delta, there is a gas liquid interface. But for this case, at x equals to 0, there is a gas liquid interface at x equals to 0, and at x equals to delta, there is a solid liquid interface. So this location from where it is starting, it will is changing actually. This is clear to everybody? Anybody has any doubt in this problem? This is the fundamental problem and very important problem actually. Okay, now we will move on to next problem.
Hello, sir.
Yeah, tell me.
Once, can you please explain that modified liquid-liquid interface boundary layer condition?
Just hold on. Look, there are three types of boundary condition in momentum transfer majorly. This is clear. Solid fluid boundary condition, no slip boundary condition means this is not a zero velocity condition. Okay, should not take zero velocity condition. This is velocity of solid liquid will be equals to velocity of solid at the interface. This is you want to know?
Yes, sir.
Okay. At liquid-liquid interface, there will be continuity of the velocity and the flux. Okay. At liquid-liquid interface, say I have oil over a water and both are flowing. Okay. Both are flowing. Oil over a water. Water has a density more, so it will be bottom layer will be oil, water, and upper layer will be oil. So at interface, the last layer of water will have same velocity as that of first layer of oil. If I am coming from the bottom, I will see water, 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 and at interface, what is happening? This is the last layer of the water, and after that I am entering oil, first layer of the oil. Both layer will have same velocity, and both layer will have same momentum flux. a magnitude of momentum flux in both layer will be same. So there will be continuity of velocity and continuity of flux at the interface. Is this clear, Pritesh?
Yes, sir.
Okay. And this is again, you can say this is modified no slip boundary condition. This condition I got from modification of this. Here solid fluid will have same velocity. Here I will have solid fluid will have same velocity but different fluxes. Again, this is liquid will have same velocity and same fluxes, and this is gas liquid interface. So now if I equate the fluxes, and got the fluxes involved viscosity and velocity gradient, so certainly velocity of gases are negligible. If I am telling that there will be continuity of fluxes here also, gas liquid interface, and if I want to equate the fluxes, the viscosity of gases are negligible. Hence flux exerted by gases are negligible, and I can take it to 0 that. So this is a gas liquid interface. Okay.
Yes, sir. Clear.
Okay. So take down this problem. Okay. So only this much given data is there. A liquid flows down the circular pipe in downward direction under the influence of pressure difference as well as gravity. Both are there. Pressure is given. Pressure can be given by external agencies also. Pressure difference and a gravity. Consider a steady state laminar flow of the fluid at constant density and viscosity mu in a vertical tube of length L and radius R. Develop the equation for flux profile, velocity profile, average velocity, maximum velocity. This is maximum. Mariam, this is not Mariam, maximum velocity, mass flow rate. Where this thing is changed, x. Oh. Okay. So somewhere this actually I have changed x, so it is changed everywhere. Just consider this x. Okay. Consider this somewhere that you need to replace x with r. Somewhere it is r. Okay. This is flux profile. Some mistake actually. I will this thing correct afterward. Okay. So develop this. Take down this problem. Think about this problem. Extract the data as much as you can. Okay, everybody has taken down this problem. Just think over this problem. Now we'll start with the given data. What is the given data? Okay. So here roll number 33 Vikram. Roll number 33 Vikram.
Sir.
Yeah. So what is this phi ij? Very good, Vikram. Roll number 40, Ravi.
Yes, sir.
What is phi ij?
Sir, it is a convective flux, sir.
Conductive flux. This
Convective. Conductive flux, sir.
conductive flux only.
Convective, sir.
Convective. It is convective or conductive?
Sir, it is a flux due to the molecular, viscous, and convective.
Okay, so this is the total flux.
Yes, sir.
Okay. So total flux consists of three components. One will be a molecular flux because of viscous forces, molecular flux because of pressure forces, and convective flux. Roll number 48, Hansraj.
Yes, sir.
So what is tau ij?
Sir, tau ij is the shear stress. Means it
Shear
is the flux
stress.
due to conductive flux.
Conductive flux. And
Yes,
what
sir.
is the generalized equation for tau ij?
Sir, it consists of two terms. First is the minus mu dv by dx means dv j upon dv dxi, and the
In
second term
short
is
form, you can tell actually that. So minus mu del v plus del v transpose.
yes, sir.
Okay, and second term is
Sir, it is the 2 mu minus k into that del v term, sir.
okay. So we will not consider second term. Why?
Sir, due to since it is a liquid, the second term means that that term is 0, sir.
Very good. So this is what. So this is total momentum flux. This total momentum flux will be a molecular momentum flux plus convective momentum flux. So this is the molecular momentum flux because of pressure forces. This is the molecular momentum flux because of viscous forces, and this is the convective flux. I varies from XYZ, J varies from XYZ, or I varies from PQR, all three directions. And this is generalized Newton's law of viscosity, which will be equals to minus mu del V plus del V transpose plus 2 by 3 mu by K del Vx, and this will not be considered in most of the cases in chemical engineering, I will say. In most of the cases in chemical engineering, this second bracket is not important, because when we are dealing with a liquid, it will be incompressible fluid. When we are dealing with a gases, this will have dilational viscosity will be 0. And here, as it is given that liquid flowing down the fluid, so this will be the equation for us, tau y x. So xy varies from, say, all three direction. Ij you can write. So this will be there. So now these are the equation used. Why flux equation is used? Roll number 59. Why we are discussing flux for this derivation? 59, Nikita.
Yes, sir.
Why we are discussing flux here?
Because you have asked for the velocity profile and the shears. So that is why we have to discuss the flux.
Okay,
And
okay.
then from this we can get the profiles that we want.
Yeah, from this we will get a rate. Okay, and we will be taking a shell balance for momentum, that is rate of momentum coming in. To calculate that rate, flux is important. So how to get flux rate from flux, Nikita?
Sir, flux is equal to rate upon area. So we'll just multiply the flux with the area to get rate.
Very good, very good. So roll number 72, Mitali.
Yes, sir.
So which coordinate system you will use here?
Sir, cylindrical coordinate system.
Okay, this is flow two pipes. So pipe look like a cylinder. So cylindrical coordinates will be suitable to solve this problem. So what are the three dimensions in cylindrical coordinate system? Three directions in cylindrical coordinate system. Mitali?
Sir, theta and r and z.
Okay, theta, r, z. R, theta, z are the three direction. So if again I will repeat the same thing. If you want to solve the same problem using Cartesian coordinate system, you can solve. Only the thing will be, it will be difficult. Difficulty level in mathematics will be very high. Okay, difficulty level in mathematics will be very high. Ultimately, you will get very complex model equation, but absolute value will remain same. It is as good as we have seen in previous cases. So you will get different model equation, but value of property will not change. Okay, at given value of r, so that will be defined by xyz. So value of velocity will remain same. Velocity will be same, direction will same, absolute value will remain same. Okay, only the thing will be, it will be represented by complex model equation. That's what. So you can solve same problem by Cartesian coordinate system also. But as our system looks like a cylinder, so we will not do, you can say, extra efforts to solve mathematics. We will stick to our cylindrical coordinate system. So roll number 76, Atharva. Roll number 76,
Yes,
Atharva. Yeah.
Yes, sir.
You should respond me quickly. Otherwise, I am writing down all the roll number who are not responding, and that will affect your grades actually at the end. Atharva.
Yes, sir.
So what are the three velocities for the given problem? Three direction velocity.
Velocity.
Yeah. Velocity in three direction.
Sir, three directions, na?
Yeah.
Hello, sir. Huh? Sir,
Which are the
VZ,
three
VR.
velocity directions?
Sir, as we are using, sir, cylindrical system, sir. So that's why Z, R, and theta, sir. We are using that systems. So
Okay, so it
VZ,
will be
R, so
VZ.
VZ, VR, and V theta, sir.
Okay, so out of these three velocity, which are non-zero and which are zero velocity? Now you assume yourself. You assume yourself as a molecule moving in the cylinder. Say if you move in cylinder in r direction, what kind of velocity you are experiencing and why you are experiencing that velocity? What kind of change in velocity you are experiencing? You assume yourself. You imagine yourself as a molecule and moving in that cylinder. So if you are moving in cylinder r direction, whether you are experiencing a velocity in r direction?
Yes, sir. It is in R direction.
Velocity will be there in r direction?
Yes, sir.
Okay, this r direction, which is r direction for this circular pipe? It is r direction is from center of the pipe and towards the wall.
Yes, sir.
Whether molecules are moving from center of the pipe towards the wall?
No, sir. In that case, it is non-zero, and
Case
VZ and
means this case is same. In that case means case is same.
Yes,
You
yes,
are
sir.
not trying
Yes,
to
and sir,
understand the thing. Okay, in that case, it is not in that case. In this case.
sorry, sir. In this case, actually, yes. Sir, then VZ and V theta will be zero, sir.
VZ. What is the VZ direction? R theta Z direction. What is VZ direction? Okay, this solution of this problem is available and I'm going to show in PPT, okay? But this is not the case actually. In future, you will get a problem without anything. Even given data will not be get there actually. You need to search the data book and solve the problem. So you should
Yes, yes.
start, just don't feel that okay because solution is available. Just this is pipe, okay? So what is cylindrical coordinate system? Where is your origin? 76 Atharva, origin.
Sir, origin from
Where will
top, no, sir,
origin?
from top center. From
Yeah,
sir, from top center, sir, from top
yeah.
center of that
Top center
cylinder.
will be the origin. So which is
Yes, sir.
your
Yes,
R
sir.
direction?
It is, sir, at the top it is origin, no, sir.
Yeah. Okay. You are telling me. Yeah. At the top center point. How many possible origins are there for this problem? Sarva? In cylindrical coordinate system, how many possible origins are there?
Sir, two possible system. Two.
Very good. There are only two possible origins. Here you will not get 8 origins. There are only two
No, sir.
possible origin in
Here not
cylindrical
yet.
coordinate system. Either
Yes, sir. Yes, sir.
the start center point or at the
Center
end
point.
center point. That's all. These are the
Yes.
two origin.
Oh,
Now say our origin at the start at the center point.
yes.
Okay. So at the start center point. So which is your R direction from origin? Atharva.
Yes, sir.
Number
Sir,
84.
from center to wall. Okay.
Center to very poor. Here roll number 84, Pradeep. Roll number 92.
Yes, sir.
You keep quiet better. It is roll number 97, Sridhar.
Hello, sir.
Yeah.
Yes, sir.
Yeah, tell me. 92.
Yes, sir.
So you will take this much time to switch on your mic.
No, no, sir. It's network
So
problem, sir.
you are not attending the class.
Sir, I am attending, sir.
Very good. Yeah, roll number 97, Sridhar.
Yes, sir.
Yeah. Can you explain R direction, theta direction, and Z direction?
Sir, the Z direction will be the length of the cylinder or the pipe.
Okay, axial direction will be Z direction. Very
Yes,
good.
sir.
Very good.
And R direction will be towards the wall, sir.
Very
From
good.
anywhere.
Towards the wall is my R direction, and theta direction.
Theta. Sir, it will be towards any side of the wall.
No. It will be whole theta will be, look, R direction you have, Z direction
Yes,
you have, perpendicular to this will be a theta direction. So theta
Okay.
varies from 0 to 180 degree.
Okay, sir.
Okay. So which velocity you have now? VR, V theta, Vz.
Yes, sir. We have VR, V theta, and VZ. Yes, sir.
Okay. So which are zero and which are non-zero velocity?
Sir, there won't be any velocity in the radial direction, that's VR will be 0.
Very good.
And we'll have some velocity in the z direction because it's falling downward.
Very good.
And so only leaves v theta, which will be 0, sir.
V theta is also 0. So
Yes.
can you give the logical reason for this? VR equals to 0.
Sir, because the liquid is falling directly downwards, so there is no force acting in the radial direction.
Okay. So first of all, you can give the reason that it is given that laminar flow.
Yes, sir.
So laminar flow is, you are telling laminar flow and you are telling that Vz is non-zero.
Yes, sir. Vz is
Laminar
non-zero.
flow. So Vz is non-zero and laminar flow. This combination of this information is telling me that Vr equals to 0 and V theta equals to 0. Because laminar flow is in layers. So 1D
Yes,
flow.
sir.
1D flow
Yes.
is there. So as Vz is non-zero, Vr will be equals to 0, V theta will be equals to 0. Second reason will be end effects are neglected. Hence Vr equals to 0. Because at the corner, okay, at near the wall, if I am moving in R direction, there will be some variation in velocity. At the wall.
Yes, sir.
At the wall, there will be some variation in VR velocity, but that is neglected. So end effects are neglected. Hence, VR equals to 0. V theta equals to 0 because problem is symmetric around the axis. If you go anywhere in theta direction, you will experience same forces. And secondly, end effects are neglected. Hence, V theta equals to 0. First of all, problem is symmetric around the axis. That is what one reason is there. Another reason is as we are neglecting end effects. Otherwise, near the wall there will be VR velocity, near the wall there will be theta velocity, everything will be there near the wall. Okay, but that we are neglecting. So end effects are neglected and problem is symmetric. Hence V theta equals to 0. End effects are neglected and we are dealing with laminar flow. Hence VR equals to 0. Okay. So this is what you can actually. So here I will write actually. So VR equals to 0 and V theta equals to 0. Okay. V theta equals to 0. Okay. And this VR equals to non-zero. Vz equals to non-zero. Now whether Vz is a function of x, y, z, r theta and z. Roll number 103, Saurabh.
Yes, sir.
Yeah. Whether Vz is a function of r, theta, and z.
Yes, sir. It is a function of R.
It is a function of r and theta.
What theta, sir? Sir, Vz is a function of R. It is
R
changing.
only r.
Yes, sir.
Why it is not a function of theta?
Sir, because in circles it's symmetrical, right? So in any radial direction, we will get the same velocity at a single point.
So this is function of r only. You are telling that it is not a function of theta because problem is symmetry. Whether Vz is a function of z.
Vz is a function of z. Vz, so it should not be.
Yeah, why? Give me a reason.
Sir, like in z direction, it only depends due to the gravitational force, right? So
Yeah.
the velocity will be whatever. It will not depend on different points on in the whole length.
Yeah, but why? What is the reason? As you have given a reason, logical reason that Vz is not function of theta because problem is symmetric around theta.
Yes, sir.
If I move in theta direction, So all molecules are experiencing same forces.
Yes,
Hence
sir.
Vz is not function. There is no driving force to change in Vz.
Same answer in the Z direction.
How?
Yeah, sir, because only gravitational force is applied in the
Say if you are standing, your pipe, consider you are a molecule and which is 10 meter above you, one molecule is there. So potential head is same. Forces acting on these forces molecules are same in Z direction.
If we are saying that if the frictional force in across the layer is acting is equals to the gravitational force, then
So
every
you are
will
telling that viscous forces are dominated over gravitational force.
no sir, like in the previous case we took the
So
viscous forces
there
will
is some difference between previous case and this case.
Yes, sir. Yes, sir. So, sir, I am saying that if that is the condition, then it will
Here that is not the
every
condition. Previous case was different case. This case is different case. Vz is not function of z. That is you are correct.
Yes, sir.
Vz is not function of z. But what is the reason behind that?
I can't think of that right now.
Anybody else? Anybody else? Nobody in 110 class. Yeah, roll number 72, Vitali.
Yes, sir.
Yeah, why Vz is not function of z? Because flow is continuous. Okay, continuity equation. So if you imagine velocity is now this is closed flow. Okay, this is closed flow. Hence, flow area remains same. Okay, cross-sectional area for flow remains same. If velocity is increasing, so there will be a discontinuity in flow because of continuity, and this is continuous flow. So continuity equation holds good actually. So this is indirectly using this equation, continuity equation. Okay. Now this is dvx by vx plus vy by dy plus dvz by dz equals to 0 for incompressible fluid. Continuous flow you will have for incompressible fluid, and this Vr equals to 0, V theta equals to 0. Okay, Vr equals to 0, V theta equals to 0. What you will get in turn? You will get dVz by dz equals to 0. Okay, that is the consequences of continuity flow, continuous flow. And this is true for closed boundary condition because cross-sectional area will remain same. For open boundary condition, it may not be the case. For continuous flow also, there may be change in a velocity in z direction if cross-sectional area for flow is changing in open flow. But this is closed boundary flow and flow area remains same using continuity equation same. Okay, this is dvr by vr plus dvz v theta by v theta plus dvz by vz equals to 0. Vr equals to 0, v theta equals to 0, hence dvz by dz equals to 0. Okay, hence vz is a function of r only. Okay, vz is a function of r only. This is everybody's got this point.
Excuse me, sir.
Yeah, tell me.
Sir, right now only gravitational forces are dominant in this case, right?
Okay.
So, sir, at different points of z along the length in the downwards direction, at different points of z, we will have different velocities of the particle because the force.
No, that
Sir,
will not be there.
acceleration
Will not be there.
Sir, why?
That is what I am telling. Continuous flow is continuous. If acceleration is there, there will be non-continuous flow.
So, sir, like how we are saying force is flow is continuous?
Just hold on. So this is say pipe. Just bear with my drawing. Can you see pipe?
Yes, sir.
So this area of pipe is say 1 meter square.
Yes, sir.
1 meter square area. And at this cross section, say velocity is 1 meter per second.
Yes, sir.
Okay. And this is velocity at this point.
Yes, sir.
Okay. So what will be volumetric flow rate?
It will be 1 meter volumetric
meter
flow
cube
rate,
per
meter
second.
cube per second.
And say density is water. Density, what is
Yes.
the density of water?
1000 kg per meter cube.
1000 kg per meter cube. Okay.
Yes, sir.
So what will be a mass flow rate?
It will be like 1000 meter
Mass flow rate
1000 kg per second.
1000 kg per second. Where at this cross sectional area.
Yes, sir.
Okay. Now you are telling that velocity will increase.
Yes, sir.
Say here velocity is 2 meter per second. What will be the mass flow rate here?
It will still be 1000 kg per meter second.
How?
Per second. So
How?
because only 1000 kg of water is going through that area.
No. You are telling the velocity is increasing here.
Yes, sir.
And we are dealing with constant density flow. Density is constant, flow area is constant. What is flow area? Flow
1 meter.
meter square per second. Okay. So flow rate will be a volumetric flow rate will be a 2 meter cube per second. And density is same. 1000. Okay. Kg per meter cube. So what will be the mass flow rate?
It should be 2000 kg per second.
From where this 1000 is coming here?
Sir, right now twice the amount is passing through that cross-sectional area.
But from where this 1000 kg? So mass balance. So this is closed boundary. So from here, if 1000 kg per second is coming, from here also it should be 1000 kg per second.
Sir, like we are saying, yeah, the amount will pass only 1000 kg, but if
What will change actually? For
if
closed boundary, you cannot change flow area. What will change? Amount will
this
pass
means
say 1000
velocity.
kg per meter cube. So velocity is increasing, you are telling.
Yes, sir.
Then from where this, what will change? Area will change.
Sir, but still, sir, let's say if we are throwing a ball downwards, right? So
No,
the speed.
that is not a continuous flow. Na? We are dealing with continuous flow. So many times this is equation of continuity. So equation of continuity is true for falling ball. Either equation of continuity is true for falling ball. If I have only one ball and it is falling down, that equation of continuity I can use. This equation of continuity is hold good for a continuous flow. Continuous flow, density is constant.
Yes, sir.
Okay. So when this will happen, so this may happen. So here now you consider packet of fluid.
Yes, sir.
Okay, packet of fluid, and here now this packet is broken down into two parts, and it is filled with air. still density is constant, but it will be a liquid, gas, liquid. Then that flow will be a discontinuous flow. Now this will not be continuous flow. This may possible when flow is discontinuous, but in liquid it will not happen because liquids are incompressible fluid. This will happen with some more volatile liquids. At extreme condition, this may happen. That time you will get a discontinuous flow. And whole of this analogy is not true for discontinuous flow. Okay, this equation is itself okay. So physical statement for this equation is continuity equation, and this is equals to density equals to constant. That we will see. What is this meaning of this is density equals to constant. So writing this constant density is one and same thing. That we will see, that too for continuous flow. Okay, that too for continuous flow. But if say boundaries are open, okay, in previous case it was flow or flat plate. So here I might get a area of 1 meter square. Here I might get an area of 0.5 meter square. Okay, here I might get an area of 1 meter square, and this say thickness of film will reduce, and in turn velocity will increase. Okay, this is film. Previous case I am talking about, but there we have taken only very thin layer. Delta is very small, where viscous forces are dominated over a gravitational force. Now clear?
Yes, sir.
Okay. So, and how about pressure now?
So pressure will be there, pressure forces.
Pressure is a function of x, y, z, r, theta, z.
In z direction.
Pressure is a function of z only. Why it is not function of r and theta?
Sir, pressure is only applied. How can I say in this? Like,
that is what engineering is. You should be a logical to all your statement. You should not just tell that because I read it, because
no, sir.
this is the case.
I can visualize in my mind that only.
Okay, that is whatever your visualization you can put in statements.
Right. Sir, like I am visualizing this only the flow, the layers of the if we take the whole fluid in different layers, the only the layers will apply the pressure in the z direction only. They will not apply.
So try to be simple as possible, so that even anybody can understand. Pressure is not function of r. Why?
Because it's not flowing in that direction. In simpler words, it's only flowing
VR
in that
equals to
direction.
0. That is one you can say, as there is no driving force. Another is there will be some variation in r direction at the wall. End effects are neglected. Pressure is not function of theta because problem is symmetric around theta. Okay.
Okay, sir.
Okay. So what are the 9 components of fluxes here?
Sir, 9 component of fluxes, it will be if we say total flux, then phi xx, phi xy, phi xz.
No. This is r theta z now.
Oh, sorry. Sorry, sir. It will be.
Okay, Saurabh. Okay, fine. Roll number 47, Gurupreet.
Yes, sir.
What are the 9 component of fluxes?
Sir, it will be phi rz, phi r theta, and phi zr, phi theta r, phi theta z, phi z theta, and phi z, phi zz, phi rr, phi r theta theta.
Okay. Theta and z. Now, can you tell me for this, what are the suffix? for this?
Sir, sir, it will be pi RZ.
RZ. This. These suffixes are very important, Guruprit. So altogether, physical meaning will change. If you are using phi RZ or phi ZR.
Yes.
So this will be a momentum in R direction. This will be due to momentum in theta direction. This will be momentum in Z direction. So what is this first suffix indicates?
Sir, it like phi RZ indicate the transfer of Z momentum in R direction.
Sure. To connect, open Bluetooth settings and look for the device called Family Room Speaker.
Aviral, can you switch up your mic? Guruprit. So this I am discussing R momentum. So how this is correct? So this is I am discussing Z momentum, how it is transported in R direction, and under this I am discussing under the VR momentum, R momentum. This will be component of R momentum.
Yes, sir.
So what will be this suffix here?
Sir, VZR.
ZR, or you can say, okay, VZR. This will indicates how R momentum is flowing in Z direction. P will be 0 or non-zero?
Sir, P will be sir, it will be non-zero because we have pressure in Z direction.
What about delta or ZR?
Delta.
This is chronicle delta. This is not thickness. This is chronicle delta.
So it will be like dvz by dvr. So we have velocity which is changing in.
No. This delta I am asking you whether you are looking at the screen and my cursor.
Yes, sir. Yes, sir. Yes, sir.
So this delta I am asking.
Sir, it will be non-zero.
I told you delta. Na? If I equals to j, then delta will be equals to 1. If I not equals to j, then delta will be equals to 0.
Yes, sir.
This is the property of chronicle delta.
Yes, sir.
So whether that is 0 or non-zero?
Sir, it will be non-zero.
So what is I equals to?
Sir, I is equal to R.
And Z, J equals to?
Z. And sir, I is not equal to J.
Then?
So, sir, it will be 0.
So what is this, man? What will be suffix here? Related row also. Where is rho? What is velocity suffix here?
Sir, it will be VRZ.
Huh? Velocity will have
VR.
two suffix.
Sir, means VR into VZ. Sorry, sir.
R or VZ into VR. It is so easy. Like you follow same thing. What will be suffix here? Mu of?
Sir, mu of dV by delta Z.
dV? Suffix.
dV, sir, dVZ by
dVZ
by delta R.
Delta R.
Yes.
This is what you will get. Okay. Then what will be second?
The second term will be del VR by del Z.
Very good. How about this second? Guruprit, suffix here.
So, so del VR by del Z. Hello?
This one, I suffix.
Sir, it will be phi theta Z. Oh, theta R, phi theta R.
So it will be phi theta R. Okay, phi theta P.
Sir, P will be 0.
Why?
Sir, because it is not changing in the theta direction.
What is this one? That is not the reason here. So this is pressure in theta direction. Pressure will not have any direction.
Yes, sir, it's a tensor quantity.
So why P is 0? Just now I explained, no, you explained to me, in fact.
Yes, sir. Because, sir, it's
So here I have equation, why this term is 0? Guruprit.
yes, sir. Uh, P delta ij is 0 because, sir, because I is equal to is not equal to j, so it's 0, sir.
Hence delta Ij equals to 0, chronicle delta. This
Yes,
delta Ij equals to 0.
Yes.
And what will be this velocity?
It will be v theta and vz. Yeah.
D theta, where is theta, and Dz.
Yes, sir. Like if we are taking phi theta and z.
So this is phi theta r, you told, no?
Yes, sir. Like I was writing every equation, sir.
So what will be second velocity?
Sir, v theta into vr.
R. What will be this?
So del v theta by del r.
Del v theta by del r plus
Del vr by del theta.
del vr by theta. Everybody want this? How to write this total flux? And what will be third component now, Guruprit?
So it will be v. Sir, vz.
We are discussing R component.
Yes, sir. VZR.
VZR. This ZR already we have discussed.
VZ. Sir, VRR.
R?
Phi RR. Oh, RR. Phi RR.
What will be value of P? 0, non-zero.
Sir, it will be non-zero because del I and J are equal, so P will be there.
What is this suffix?
Sir, it will be VR into VR, that is VR square.
Very good. How about this?
Sir, it will be dVR by del R. Like it will be 2 times, so sir, it will be minus 2 mu del VR by del R.
Very good. So now everybody please write this, complete this suffix. Roll number 9, Nitin.
Hello, sir.
Yeah. So can you tell me? You start with this suffix.
Sir, it will be VR theta.
VR theta.
Yes, sir.
Theta. P will be 0, non-zero.
Sir, it will be 0, sir. Delta r theta is 0.
Very good. And which velocity here?
Sir, rho Vr V theta.
Yeah, V theta. So easy actually, very easy. This will be a
Dou Vr by dou theta and dou theta by dou Vr. Sir, dou r, dou r.
so theta, na? VR by
Yes,
V
sir.
theta.
Plus
So
dou theta by dou r.
theta by dou r. Everybody is getting this? Roll number 23, Kaushik.
Yes, sir.
So which component you want to tell now?
Like phi theta theta.
Phi, theta,
Theta.
theta.
Theta. Yes, phi theta theta. P will be P only, sir. Like
Just hold on.
Yes.
Phi theta theta. P will be 0, non-zero.
Non-zero, sir.
Non-zero. And this will be a
And rho V theta theta. V theta V theta.
theta, V theta. Okay. And this will be
And dou V theta by dou theta plus dou V theta by dou theta.
very good. Nice. Correct? Here roll number 28. Huh? Roll number 28. Roll number 37, Vignesh.
Am I audible, sir?
Yeah, you are audible. You tell me what is the third component?
So for phi ZZ, it will be P plus rho.
No. This third component I am asking.
Okay, sir. Z theta. Phi Z theta will be as I not equal to J in this case. So canonical delta would be 0. So it would be rho Vz V theta minus mu dou Vz by. Hello, sir.
Oh yeah. You are fast. You are faster than me. I am hard. Then
Minus mu into dou Vz by dou theta plus dou V theta by dou Z.
so fast actually. Dou Vz by dou theta plus dou V theta by
dou Z, sir.
dou Z. Okay. Roll number 53, Shivam.
Hello.
Which component you want to tell me? You are not properly audible.
Yes, sir. ZZ. Phi ZZ.
Phi ZZ you want to start. Okay. Phi ZZ.
Yes,
P
sir.
will be 0, non-zero.
Non-zero. It will be P only.
Why?
Sir, dou Ij is like dou ZZ it will be. So it will convert into 1.
Okay. Then
Rho Vz into Vz minus mu into dou Vz by dou Z plus dou Vz by dou Z.
Okay. Roll number 69, Mehul. Roll number 69.
Yes, sir.
खाना हो गया?
Hello.
हाँ बोलो.
Yes, sir.
कौन सा कंपोनेंट बोलना चाहते हो?
Sir, tau r theta.
Theta?
Sorry, phi r
phi r
Phi r z, sir. Phi r z.
r z. तो p क्या जीरो है नॉन जीरो है?
P P non-zero, sir.
क्या है यार, कितना बताना पड़ता है यार, कितना बताना पड़ता तुम्हारे को? p नॉन जीरो है क्या? चलो मैं
नहीं सर.
बताता हूँ p जीरो है। अभी रीजन बताओ, तुमने 10 बार बता दिया मैंने रीजन। क्या है रीजन?
सर I not equal to j, इसलिए जीरो होगा.
इसलिए क्या जीरो रहेगा?
P
p जीरो रहेगा क्या?
डेल्टा जीरो रहेगा.
हाँ, क्रोनिकल डेल्टा जीरो रहेगा। यहाँ क्या रहेगा? कौन सा सफिक्स आएगा?
R
r। यहाँ कौन सा आएगा?
Z
z। यहाँ क्या आएगा?
R
r। और पूरा बताओ ना अभी।
सर dou VR by dou VR by dou VR by dou Z plus dou VZ by dou Z.
dou vz by dou z।
नहीं सर, dou VZ by dou VZ by dou R.
वेरी गुड। टू मिनी विंडो है, 2 मिनट विंडो नहीं है। हाँ, हो गया।
Yes sir.
मेमोरी फुल हो गई। कहाँ से इतने विंडो ओपन है? इतने तो विंडो ओपन ही नहीं है। कौन बताएगा ये? रोल नंबर 79 प्रशिक। 79 प्रशिक। रोल नंबर 101 रितेंद्र।
यस सर।
हाँ, कौन सा कंपोनेंट बचा है देखो पहले अभी।
यस सर। हेलो।
हाँ, क्या लिखो इधर?
79 sir.
थीटा जेड इज रिमेनिंग सर।
थीटा जेड ओनली। सो दो सफिक्स रहेंगे ना?
हाँ
बताओ क्या है?
सर फाइ थीटा जेड ना, मतलब वो फाइ और फिर सफिक्स में थीटा जेड।
अच्छा अच्छा, फाइ थीटा जेड। पी जीरो नॉन जीरो?
सर पी जीरो।
जीरो। हियर विल बी बी थीटा
वी थीटा जेड।
वी थीटा जेड। वेलोसिटी को दो आएंगे क्या?
सर वी थीटा देन वी जेड थीटा जेड।
ओके, यहाँ क्या आएगा?
सर डी वी जेड बाय डॉ थीटा। So and dv theta by dou z.
V theta by
Dou z.
dou z. Everybody got this? Roll number 4, Aditya.
Yes, sir. Yes, sir. Sorry, there is lag, sir.
हाँ, तो इसमें क्या क्या जीरो है, नॉन जीरो है?
सर फर्स्ट में रो VZ VR 0 होगा क्योंकि VR 0 है
वेरी गुड.
सर. और VZ R में वेरी कर रहा है तो डो VZ बाई डो R रहेगा टर्म.
हाँ.
और डो VR बाय डो Z 0 होगा क्योंकि वेलोसिटी R वाली वेलोसिटी Z में वेरी नहीं कर रही.
R वाली वेलोसिटी नहीं है, ठीक है?
हाँ सर, वो है ही नहीं मतलब.
और रोल नंबर 8, अली.
यस सर.
इसमें कौन सा जीरो रहेगा, नॉन जीरो रहेगा?
Sir, first term will be 0, sir, because sir, v theta equal to 0.
Very good.
And sir, VR also 0. And sir, del v theta by del R.
पूरा ही
So
जीरो
v
है
theta
ये.
equal to 0, sir. Yes, sir.
पूरा ही जीरो है
Del
ना?
v. Yes, sir, पूरा 0.
ओके. तो ये जो है नॉन जीरो कौन से है? इंसर्ट शेप.
So del v z by dr.
नॉन जीरो है.
Yes, sir.
Okay. और दूसरा नॉन जीरो कौन सा है? ये तो पूरा ही जीरो है ना? ये पूरा जीरो है क्या?
Yes, sir. Yes, sir.
हाँ?
Yes, sir.
ओके.
Yes, sir, पूरा 0.
इसमें क्या जीरो है, नॉन जीरो है?
Sir, p is non-zero.
P is नॉन जीरो.
Yes, sir.
और बाकी के?
And बाकी के सर 0 सर दोनों में VR and V.
क्यों? क्यों?
VR 0 ना दोनों के.
VR जीरो है, ठीक है? VR जीरो है.
Yes.
रोल नंबर 10, अमन.
यस सर.
इसमें क्या क्या जीरो है?
सर इसमें सारे जीरो हो जाएंगे सर, क्योंकि वी आर और वी थीटा दोनों जीरो है.
अच्छा. इसमें
पी नॉन जीरो सर, और बाकी सारे जीरो.
P नॉन जीरो है, बाकी सारे जीरो है. V थीटा जीरो, V थीटा जीरो. हाँ. इसमें
फर्स्ट टर्म जीरो क्योंकि वी थीटा जीरो है, और सेकंड टर्म में आ जाएगा माइनस म्यू डी वी जेड बाई डी थीटा.
ये नॉन जीरो है क्या?
नो सर, ये भी जीरो है क्योंकि वी जेड इज चेंजिंग इन with respect to r, so it will also be zero.
Why Vz is not changing in theta direction?
Sir, because end effects are neglected. Sorry, because the problem is symmetric.
Very good, very good. And ये क्यों जीरो है?
So क्योंकि v theta जीरो है क्योंकि सर symmetric है problem.
And moreover, we will not consider all these 6 components. Why we will not consider all these 6 components? Because we don't have velocity in r direction. Velocity in theta direction is also 0. Hence, we will not take a balance of r momentum. We will not take a balance of theta momentum. This is clear to everybody? Even though these are non-zero, this P is non-zero, this is non-zero. If I take a balance of this, input will be equals to output. I will not get anything. Because VR equals to 0, I don't have R component of velocity, I don't have theta component of velocity. This balance need not to be taken. It doesn't mean that I don't have fluxes in that direction, okay? Fluxes in that direction. Fluxes are non-zero. This will be pressure fluxes, this will be viscous fluxes. But if we take a balance of R momentum and Z momentum, so as Vz is not function of theta and this Z, okay, Vz is not function of theta and Z. input will be equals to output for all these three components, and ultimately it will be, you will get P equals to P, or 0 equals to 0, or tau RZ equals to tau ZR. That is what you are going to get out of this. So we will not consider this. Okay, we will not consider this. So this will be this. So okay, this will not be considered, and this will not be considered. Okay. Anybody has any doubt? Anybody has any doubt? Because I don't have VR velocity. This is just a first problem, hence we were discussing how to get this component. There are 9 components and everything. So your understanding will improve. That's all. Otherwise, you can start the problem with this only directly. As I have only Z velocity, so Z momentum, and that's all. So now tell me, what are non-zero terms in this Z momentum component? Roll number 29, Vedant.
Yes, sir.
Yeah, zero term, non-zero term. Which is non-zero term?
Phi ZZ will have P non-zero. Rho VZ will also be non-zero as we have velocity in direction. And
Okay.
dou VZ by dou Z will be zero because the velocity is not changing in Z due to the continuous flow.
Okay, so this will be non-zero. This two term will be non-zero, isn't it?
Yes, sir.
And why Vz is not function of Z?
Because we have a continuous flow in a closed boundary here. So
Very good, very good. How about this Rz?
in RZ, VR is zero, so the convective term will be zero.
Huh?
dVR by dZ will also be zero because again VR is zero. But we will have dou VZ by dou R term because VZ has a variation in R direction.
Very good. So only non-zero term will be this. Okay. And in third?
Sir, in third, sir, the whole term will be zero because V theta is zero and VZ does not change with theta.
Huh?
In dou V theta by dou Z
So
also
then
zero
everything
because
is zero.
yes,
Everything
sir.
is zero. Only non-zero terms are this one. So
Yes, sir.
how differential shell will look like?
Sir, it should be like a very thin cylinder, uh, like at a distance r from center.
Okay, so differential thickness will be taken only in the direction. Which direction?
R, sir.
R direction. Why?
Sir, because we have variation in R direction for
Very good, very good, excellent. So I will take a differential thickness only in R direction. Theta, what is the total boundaries of the theta? I will take for complete boundary. Theta varies from, what is the minimum and maximum limit of theta, Vedant?
from 0 to 180.
0 to 180.
Yes, sir.
0 to 180 degree for theta, and Z varies from Vedant?
Z will be from 0 to L.
Very good. So Z varies from 0 to L, total length of the pipe. Theta varies from 0 to 180 degree, total value of theta, and only R varies from starting at any value R and end at the R plus delta R. So what will be the perpendicular surface area to phi ZZ? Roll number 58, Devang.
Yes, sir. Sir,
What
it will be
phi
2 pi.
ZZ, perpendicular surface area.
Sir, it will be 2 pi r into delta r, delta r
Very good.
thickness.
Very good, very good. So you are reading from slide or you know this?
No, sir, I am doing like
Very good,
I,
excellent, excellent, excellent. What is the perpendicular surface area for phi RZ?
phi rz. Sir, it will be 2 pi r l
2 pi r into L inside
Yes.
that will be surface area for cylinder. Okay, if you
Yes.
understand this, remaining is mathematics. This is what the transport phenomena is there. Remaining just the mathematics. Okay, remaining is just a mathematics. Just I will again summarize the thing what we have discussed actually. So this is what generalized method we are going to follow. Okay, first we will select the coordinate system, then we'll identify non-vanishing velocity component, then write a momentum balance equation, then thickness approaches to zero, so we'll get a differential equation in r direction because properties are changing in r direction. Integrate the equation. This is flux actually, momentum flux. Okay, just read it flux. Okay, somehow it change exchanges to r. So integrate the equation, you will get a momentum flux distribution. Then use Newton's law of viscosity and you will get a velocity equation. Integrate the equation and use boundary condition. So you will get a velocity profile equation. Okay, velocity distribution. Now once you got a velocity distribution equation, you can get a various quantities such as the maximum velocity, average velocity, force on solid surfaces, and so on. All these things you can get it by using velocity profile equation. So, so boundary condition. So how many boundary conditions are needed to solve this problem?
Three
Roll
boundary
number
conditions.
6, Aksh. Roll number 6, Aksh.
Yes, sir.
How many boundary conditions are needed to solve this problem?
So 3 boundary conditions would be needed.
Why 3 boundary condition?
So that would only so 3
We have-
variables we are dealing with.
Now Vz, we have only one velocity and it is varying only in one direction. So we need a 2 boundary condition. We need a 2 boundary condition to solve the problem. This boundary condition either I want one flux and one velocity condition, or I want 2 velocity condition. Then only I can solve the problem because problem is varying only in one direction. Okay.
Yes,
so
sir.
there is one boundary condition available, solid fluid interface. What is that boundary condition?
Sorry, sir. Can you please repeat once again what you're asking?
There is one boundary condition available for this problem, solid fluid interface plane, no slip condition. What is that boundary condition? One boundary condition is available of A type. No slip boundary condition is available given in a problem. What is that no slip boundary condition given in a problem?
So at wall of pipe, we can apply.
So what is that
Wall of the
value?
pipe.
What is that boundary condition? Can you put in mathematics then, mathematical equation?
So we can do that now. In this boundary condition, we know the velocity of solid will be equal to the velocity of the fluid.
Okay.
So it would be no slip boundary condition. So the velocity of the last layer would be equal to velocity of the wall and zero, like that, because it's
Okay. So
that we can say.
we at r equals to capital R, radius of the pipe. At small r, okay, geometrical location r equals to radius of the pipe, capital R, the velocity Vz equals to 0. That is one boundary condition. Any other boundary condition is available, Aksh?
Sir, we need two, so there must be one.
Yeah.
One is this, sir. One is for solid fluid interface, and sir, rest, sir.
Okay, we'll see whether we have any other boundary condition. Anybody is aware of any other boundary condition which we can take it from problem? Anybody in the class?
Sir, at r is equals to 0, gradient will be 0, velocity, Vz gradient will be 0.
Okay. That you can for that information you need some mathematical input, because this I know velocity is 0 at r equals to r, and problem is symmetric, means r is coming to 0 and second time again r is increasing. Certainly r will be maximum at the center. So at the center, so gradient will be 0. So that is condition for maximum. That is coming from mathematics. That is one boundary condition you can say. Otherwise, logically also you will come across that boundary condition. That is called as a logical boundary condition. We'll see. So gradient, everybody got this point? Gradient of velocity will be equals to 0 at r equals to 0. Because r is increasing in both the direction. So from center towards the wall, r is decreasing and Vz is decreasing. Okay, velocity is decreasing from center to wall. Velocity is decreasing at every direction. So certainly velocity will be maximum at the center. Velocity will be maximum at the center means gradient will be 0 at the center. Condition for maximum that we can use. Okay, so gradient is 0 means flux will be 0. Okay, so that we'll see whether how to use that boundary condition. So this is my pipe. Okay, this is my pipe and this is the direction of the flow. This is the direction of the flow. So, and this is my r direction. So I can there are only two options available for selecting origin. One will be a top center, another will be a bottom center. So this will be my r direction. The direction from the center to the wall will be my r direction. Direction parallel to axis is my z direction, and this will be my theta direction. Okay, the direction which is perpendicular to both the direction. Okay, this direction. Okay, this direction. So r varies from 0 to capital R. R will be the radius of the tube. Z varies from 0 to L. L will be the length of the pipe, and theta varies from 0 to 180 degree. Okay, this is 0 to 9, not 180, 360. Okay, not 180, it is 360. This is 90, this is 180, this is 270 and 360. Theta varies from 0 to 360. Please correct. So in previous discussion also we wrongly taken it as a 180. So theta varies from 0 to 360. It is not 180. So this will be 90, then 90, 180, 180 plus 90, 270 and 360 degree. So this is the coordinate system. So and differential shell, because this will be my differential shell. Differential shell theta varies from 0 to 360 degree. This theta. Z varies from 0 to L, and R varies from this say small r, any value of R to R plus delta R. This will be my differential shell, because my velocity is varying only in r direction. I have only Vz velocity which is changing only in r direction. So this will be my momentum flux. Okay, so this will be phi rz. So perpendicular area to this phi rz will be a twice pi r into L. Okay, this is twice pi r into L. This surface area phi zz. So perpendicular surface area will be twice pi r into delta r. Okay, twice pi r into delta r. So this will be differential shell. So I can take a balance over this differential shell. Rate of momentum coming in minus rate of momentum going out plus generation of momentum plus consumption of the momentum equals to 0. What will be the total forces acting on this differential shell? Total forces acting on this differential shell. Roll number 17, Leshma.
Yes, sir.
Total forces acting on this differential shell.
Sir, force will be mass into g, acceleration due to gravity.
Okay,
Mass
how
will
to
be
get? Okay, density into volume.
Yes, sir.
Into volume. And how to get the volume of this differential shell?
Sir, volume will be 2 pi r into length into delta r, sir.
Very good. So I am talking about this volume of this differential shell, not volume of a cylinder. This will be volume
Yes.
of a differential shell. If that is there, so problem is solved actually. This is rate of z momentum because I have z velocity. So z momentum coming in across the surface at z equals to 0, which this arrow I am talking about. Okay, this here actually z momentum coming in my differential shell in z direction. So z momentum coming in at z equals to 0, okay, in z direction. That will be I zz multiplied by this surface area. This surface area is twice pi r into delta r. Okay, this surface area I am talking about. This surface area, total surface area. This is cross section is taken. So total surface area, this will be a twice pi r into delta r. Okay. Now similarly, this will be a rate of z momentum going out in z direction. Z momentum going out in z direction, that will be at z equals to L. That will be phi zz multiplied by twice pi r into delta r, phi zz estimated at z equals to L. Okay, this is phi zz estimated at z equals to 0, phi zz estimated at z equals to L. So rate of z momentum in across at the cylinder at r. So which surface I am talking about? This arrow. This arrow I am talking about. This will be a rate of z momentum. Velocity is there in z direction coming in the differential shell in r direction. That will be phi rz estimated at r. Okay, that will be multiplied by surface area will be twice pi r. Okay, that is twice pi r into L. So that will be inside surface area. So twice pi r into L. So that will be twice pi r into L. Pi rz estimated at r plus at r. Okay, that this is rate of z momentum in across the cylinder at surface r. Rate of z momentum going out from my differential shell at r plus delta r in r direction. That will be a surface area of outer surface of the shell. Outer surface, the radius of the outer surface is r plus delta r. So that will be twice pi r plus delta r into L, pi rz r plus delta r. As delta r is very small as compared to r. Delta r is a differential thickness and taken to be very small. So I can neglect this, and that will be equals to twice pi r L pi r z estimated at r plus delta r. So indirectly I am telling that inside surface area will be equals to outside surface area for smaller value of delta. Delta tends to 0. When delta r tends to 0, inside surface area will be equals to outside surface area. So total forces acting because of gravity. Gravity is there in z direction. So G. Okay, positive z direction, gravitational direction is matching. So in the direction of flow, this is in the direction of flow. So this G, acceleration due to gravity, multiplied by mass. Okay, this mass into acceleration will be force, and this mass will be a volume into density, and this will be a volume twice r pi r delta r into L. Okay, twice pi r delta r into L into rho g. Now rate of momentum in, this is in, this is in, minus rate of momentum out, this is out, this is out, plus generation and consumption, that is equals to 0. So this is my shell balance equation. Okay, this is, say you can see, this is rate of momentum coming in, this is the rate of momentum coming in, this is the rate of momentum going out, this is the rate of momentum going out. This is in r direction, this is in r direction, this is in z direction, this is in z direction. Okay, plus total forces acting on this system, that will be twice pi r plus delta r L to rho g equals to 0. This will be a overall shell momentum balance equation. Now hereafter it is just a mathematics. So you need to rearrange the equation such that, so I will be dividing this equation by all constant. Okay, this r is not a constant. Okay, so don't change the location of r. So all constants means 2 is constant, pi is constant, L is constant. So this here you can say all other constant you can divide. Okay, divide by constant and rearrange the equation such that I will get a differential equation with respect to r. So and define using the definition of differentiation. Don't change the location of R because my property is changing with R. Okay, there is a variation of property with respect to R. My properties are changing in R, so don't change the location of R. Only what you can change is all other constant. 2 is constant, pi is constant, L is constant. This you can change the location. So accordingly, and use the definition of differentiation. Okay. So use the definition of differentiation and rearrange the equation. So you will be getting this equation. Just check what are the rearrangement made. Okay. What are the rearrangement made to get this equation? What all rearrangement made to get this equation? Roll number 31. Roll number 31.
Yes, sir. Hello, sir.
Tell me.
We
Tell
need
me.
to multiply with negative, sir.
We need to multiply it by negative signs. You can see here. This is negative and this is positive. This is okay. This is positive. So this is negative. And direction is changed. Okay. For this, it was before equals to, now it is after equals to. So whole equation multiplied by -1. And what other thing you have done? Roll number 31.
Yes, sir.
What other thing you have done?
Divide by 2 pi L delta R.
Divide by 2 pi
L delta R.
Very good. Divide the equation by 2 pi L into delta R.
Yes.
Multiplied by -1. Rearrange the equation. So you should be able to get this equation. Yeah, anybody not getting this equation? Yeah, anybody not getting this equation? Okay, rearranging this equation and using the definition of differentiation. What is this? Delta R tends to 0. Property at R plus delta R minus property at R. Any property, this can be any property at R plus delta R minus property at R. F of F at R plus delta R minus F at R divided by delta R, and delta R tends to 0. That is the definition of differentiation, d by dr of R into phi R. Why we are not changing this location of R? Because my properties are changing in R direction. My properties are changing in R direction, so R is a variable actually. Independent R variable actually, independent variable R. That will be equals to phi zz at z equals to 0 minus phi zz at z equals to L divided by L plus rho g into R. Now I can substitute this definition of phi rz and phi zz. Substituting phi rz, so phi rz will be equals to tau rz plus rho into Vr into Vz. Phi zz will be equals to P plus tau zz plus rho into Vz and tau zz equals to 0 because there is no variation of z velocity in z direction. Substituting it here and rearranging the equation. Substituting it here and rearranging the equation. So I'm using the definition of this is generalized Newton's law of viscosity. So anyway, this is generalized Newton's law of viscosity for cylindrical coordinate system. Okay. For cylindrical coordinate system, this is generalized Newton's law of viscosity. Okay, so rearranging, substituting everything. Okay, here, so this is this phi tau rz will be equals to mu vr by vz, and this tau zz, and this will be equals to 0. substituting this equation and rearranging the equation. Substituting this, everybody is following. Okay, now here you can see there is a slight rearrangement here. So all pressure terms are rearranged. Okay, rho into G is kind of pressure. Rho GL. Okay, rho GL is a, you can say, potential head. Rho GL. And this is the pressure given by external agents like pumps and all. So this is coming from a molecular momentum flux because of pressure forces, and this is coming from gravitational force. So this is also pressure, this is also pressure, and actually we are measuring combination of the two all the time. Whenever I am measuring the pressure gauge pressure will be a, all the time it will be measuring this pressure plus potential head. So pressure plus potential head, this is the pressure plus potential head at Z equals to 0. This is 0. This is 0. This is the measurable pressure at Z equals to 0, and this is the measurable pressure at Z equals to L, whether PL is a pressure exerted by external agency like pumps and all purely, and this is pressure because of potential head. So this potential head is higher. So you can see negative L, minus L. This is minus 0. Here potential head is 0. This potential head is negative rho GL because I am moving in a direction of gravity actually. Okay, my origin is at the top and end of the pipe is at bottom. So at bottom the potential head will be lower. Potential head will be lower and flow will be in that direction. Okay, potential head, and this is PL. Certainly this will be lower than this, and this is indicated by capital P0. Capital P0 is a measurable pressure. All the time I will be measuring a pressure given by pump and a potential head. That combination only I will be measuring. So that is what you can say this is called as a gauge pressure. This is gauge pressure. P0 is a gauge pressure, which is a combination of all the pressure given by external agency like pumps and all plus potential head. And this is PL. PL is the pressure at length L. Okay, so d by dr of r into tau rz will be equals to delta P divided by L into R. Everybody got this point? This is the pressure exerted by pumps and all. Okay, and this is the potential head. And this measurable pressure will be combination of both the pressure. Okay, so rearranging this equation, so this is what I will get. Rearranging and integrating this equation, tau rz will be equals to delta P or P0 minus PL divided by twice L R plus C1 divided by R. Now here either I can use at R equals to 0, tau rz equals to 0 or logical boundary condition. This is called as a logical boundary condition. What is logical boundary condition is at any corner of my geometry, at any corner of my system, a measurable property cannot have undefined value. So if say C1 is there, C1 is say any non-zero value at R equals to 0, say C1 equals to 10, 10 divided by 0 is undefined. So at R equals to 0, tau rz is undefined. Okay, so logically I should not have this term in my model equation. What is logical boundary condition? All the term in my model equation which is giving me undefined value at any corner of my system, that should not be there in model equation. Here at R equals to 0, tau rz is undefined. If C1 is there, this term is there. So at R equals to 0, tau rz is undefined. So I will eliminate this. This is called as a logical boundary condition. What is this logical boundary condition? This logical boundary, in addition to this, we will add one more boundary condition. That is logical boundary condition. What is logical boundary condition? Tells me that at R equals to 0, tau Rz is finite. Okay, at r equals to 0, tau Rz is finite, means this term should not be there in my model equation. This term should not be there in my model equation. So tau Rz will be equals to P0 minus PL divided by 2L into R. This is called as a logical boundary condition. This is clear? Anybody has any doubt till this point?
So can you explain this new boundary condition again?
Yeah. So look, tau Rz is a measurable property. Okay. This is the Z momentum flowing in R direction. It has some physical significance. So in my given system, this measurable property should not have undefined value at any point in my system. Any point in my system. I cannot say temperature is undefined in my system. I cannot say concentration is undefined. I cannot say mass flux is undefined. I cannot say heat flux is undefined. I cannot say momentum flux is undefined anywhere in my system. Now, if say this term is there in my system, so certainly at 0 equals to R equals to 0. If say C1 equals to any value, C1 equals to say 10. So at R equals to 0, 10 divided by R is undefined. So this whole model equation will be undefined. At R equals to 0, that is not possible in physical system. So at R equals to 0, tau Rz is a finite. It is not undefined. It has some finite value. It can be 0 or anything. It can be 0, non-zero, but some finite value is there. So consequences of that is this second term should not be there in my equation. That is a logical boundary condition. Is it clear to everybody? Otherwise, say you take C1 constant. This is constant. It can be anything. It can be say 100. It can be 200. Anything. So at R equals to 0, say I will get this C1 equals to say 100 by R. And at R equals to 0, I will get undefined. 100 divided by 0 is not 0. It is undefined. 100 divided by 0 is not 0. It is undefined. So at R equals to 0, I will get tau Rz equals to undefined. That will not be there with any of the physical measurable property. Physical measurable property cannot have value undefined at any corner of my system. That is happening with this term at R equals to 0. Hence, this term should not be there. Sometimes people will write C1 equals to 0. 0 by 0 is also undefined. But that is, in some way, it is wrong. So, correct way is telling that at R equals to 0, tau Rz is finite. So, this term should not be there in my model equation. So, this is the flux profile equation. P0 minus PL divided by 2L into R. This is okay. So just I will go through whatever we have covered. We are not covered much today. Anyway, so we continue this discussion. So this was the problem. So we have started this and then discuss this. Anybody has any doubt? Just go through these slides and just let me know if you have any doubt.
Excuse me, sir.
Yeah, tell me.
So could you please explain this P naught minus rho G naught, that expression, how,
Okay.
why we have modified it? So I could not
Okay,
understand.
look, generally pressure is measured by, say, pressure sensor. Okay, consider that any pipe is given and you want to measure the pressure. So pressure gauge, have you seen pressure gauge?
Yes, sir.
So which pressure it is measuring? It is measuring a pressure which is given by pump or hydrostatic pressure. Which pressure it is measuring? There are two pressure. One is a hydrostatic pressure. Just because of liquid head there will be pressure, or you can say potential head, that is also called as the potential head. One is the pressure given by the pump in a pipe. So which pressure is measured by pressure gauge? That is actually combination of both. Okay, that is combination, that will be pressure, and because this flow is in negative direction, so negative sign is coming, plus rho g into h. Okay.
Yes, sir.
So this is what pressure we are measuring using pressure gauge. Hence this pressure, okay, this equation is rearranged. Okay, this equation is rearranged using this pressure, and this is rho g into r. This rho g into r is also a potential head. So we have rearranged this in this form actually. We have rearranged in this form. Okay.
Yes, sir.
So this is the measurable pressure. My pressure gauge is measuring this capital P all the time. It is not measuring only pressure given by pump or a potential head. And this is because this negative sign is coming. So potential head at the bottom will be lower. Hence minus L is there, and this is minus 0. This is 0 only. This is rho GL. This is R at L. So you can see. So if you go here, this is R estimated at L. Rho GL. Here PL rho GL. Okay.
Yes.
And divided by L. So this L equals to 1. This 0 divided by L will be equals to 0. So this is actually rho G only. This rho G is adjusted here with this term. Here rho VZ will get cancelled. Why rho VZ will get cancelled?
Rho VZ.
Why this term is not coming here?
So because it's on both the sides, so it's getting
Yeah.
cancelled.
Yeah, because at z equals to 0, rho VZ will be equals to, at z equals to L, rho VZ. So that will be equals to 0. And this is pressure. Pressure is a function of z. So P0 is the pressure. This is the pressure given by external agencies like pump. That will be P0 and PL. Now this is the potential head at z equals to 0, and this is the potential head at z equals to L. This negative sign indicates flow is in downward direction. Okay, as I'm moving in a direction of flow, potential head is decreasing. That is indicated by this negative sign. If my flow is in positive direction, this will be positive. Okay, if flow is against the gravity, as I am moving in a direction of flow, my potential head is increasing, then this will be positive. Okay, and this is what pressure is measured actually. This is measured pressure, you can say. Okay, so everything is in the form of measured pressure. So measured pressure consists of two pressure. One will be the pressure exerted by any external agencies like pump, and another will be just a gravitational force.
Okay, sir.
So sometimes there will not be this small P0. So you will not, like tank is there. Okay, water is flowing from the tank. So that P0, small P0 will be 0. So capital P0 will be just a potential head. Flow is because of potential head only.
Okay,
Is
sir.
it okay?
Yes, sir.
Okay, anybody else has any doubt till this point? Okay, then we'll continue our this discussion in next class. So thank you very much. If you have any doubt, you can just tell me. Otherwise, we can close down this class.
Excuse me, sir.
Yeah, tell me.
Sir, this doubt is about VZ. Sir, we are saying from continuity equation that VZ is not varying in the Z direction. But sir, from
Yeah.
continuity equation, we can only comment on average VZ, right? Because
No, no.
from continuity equation, we can say average velocity into rho into area.
No, that is not average velocity. That will be local value actually. That control volume can be as small as molecule also, no?
Okay, so for the molecule we are considering only.
Yeah. That control volume. So what area of concern we are taking, that can be as small as molecule also.
Okay, sir, got it.
That is not only average velocity. That will be overall local value also will not change in Z direction. So, and that indirectly we are telling laminar flow also. If say you are telling that okay, local value will change, but if say local value will change, that momentum will be transported in other momentum direction. So it will violate that laminar flow definition actually. So it will be all combination of this thing actually, combined effect of laminar flow is there, continuity equation is there, density is constant. Hence Vz is not function of Z.
And also that force of like gravitational force is balancing force of viscosity. This can be also the reason, right?
No, no, no. Here that cannot be a reason actually. Because here pipe diameter can be as small as in mm. If it is say